My name is Netta Sandrini. I'm an assistant professor in agri-food law at Wageningen University in the Netherlands, and I will perform a legal and regulatory assessment at the Tolerate project. And from a legal perspective, I can say that Tolerate seeks to show how the law can act as a facilitator rather than acting as a barrier for sustainable innovation. This project will explore how innovation can perfectly match with the sustainability goals of the major European food and agricultural policies, such as the European Green Deal and the Farm to Fork strategy, ensuring that the project can contribute to climate resilience and biodiversity goals. So we will also assess how legal innovation in this sector can make this tool accessible to small businesses, enabling a more inclusive, sustainable transition.
I'm Nitko Mariani, and I represent Ecotech Systems in the Tolerate project. Ecotech Systems is a research company based in Italy, and in this project we are responsible for assessing the eco-compatibility of products and molecules produced by the consortium. This objective will be achieved by using a battery of ecotoxicity assays, which consist of exposing to selected organisms the products and molecules produced by the consortium. So these organisms have been selected based on their physiological characteristics, and their response will help us to quantify the products to be introduced in the environment without hazards and without danger for the environment.
My name is Amelia Perfumo, and I work at the Alfred Wegener Institute in Germany. So Tolerate's ambition is to enhance crop resilience to climate change, which is a critical step towards ensuring sustainable agricultural productivity in the face of global climatic challenges. A lot of research we know is already ongoing that is focused on developing crop varieties that are better adapted to warmer climates and drought. But Tolerate really stands out because we focus on soil microorganisms, and particularly those living near plant roots, which what we call the rhizosphere. And they play a crucial role in supporting plant health, and this is especially under stress conditions. So Tolerate's primary objective is to identify key microbes and their functionalities that enable plants to better adapt to climate extremes. And to achieve this, we look back in time, hundreds of thousands of years ago, when the planet already experienced warmer climates, and plants and their microbiomes likely already evolved natural adaptations to changing environmental conditions. So this is really the very unique perspective of Tolerate. We do this by studying the ancient DNA that is preserved in old sediments that gives us a genetic fingerprint of past ecosystems and also tells us how they might have adapted to climate. So then, once we have identified these genetic sequences and their functions, the second big objective of Tolerate is to bring them back to life. And we do this by cloning and expressing these ancient genes in modern bacteria. And ultimately, we test them with plants to see if they really improve resistance to heat and drought. So overall, Tolerate looks to the past to help solve some of today's challenges, such as climate change, basically by developing innovative, nature-inspired solutions to make crops stronger and more resilient for the future.
Hi, I'm Steve Houston from Hamilton University in Edinburgh. And my question is, how can Tolerate contribute to the EU's vision for adaptation to climate change? The EU has a vision which is going to be set out over the next 30 years, and they have four objectives. The first one is how we can adapt more quickly, because climate change is happening now, and we have to respond to that. So how can we introduce new technologies, new ways of thinking that allow us to be smart about our responses to climate change, but also how we can be quicker about that, because climate change is happening now, and we have to act now to mitigate any those reasons. They also want to try and increase international action. So what can we do that allows other parts of the world to react to climate change better? And also they need to involve all levels of society, so be more systemic, to get everybody involved in that. So the way Tolerate can do that is we're basically coming up with new technologies that can be used, or we will come up with new technologies that hopefully will be able to be used by farmers so they can plan better their crops, so they can react better to either floods or droughts situations. That also then contributes to an improved food supply and a more secure food supply. In terms of climate emergencies. We're also coming up with hopefully technologies that can be used by everybody. So simple technologies that could be applied not just in the first world, but also in the third world. And again, that will secure food supplies.
Hello, my name is Fatih Borakeskin. I am the CEO of the Molkin Industrial Products Company. We are based in Izmir, Turkey, and we are working on the surface solutions for the industrial applications. Our main target in this project, in the Tolerate, that we, according to the project, we gained the surfactants, which is produced by the microorganism, and we are aiming to them as an alternative to the synthetic chemical-based biosurfactant. As an end user, we will use this gained product in our formulation of the industrial cleaning chemicals and metalworking solutions.
Hello, I'm Sodiris Kirago from the Cyprus Institute of Neurology and Genetics, and I am the leadership of Work Package 5. In this work package, we aim, among with my collaborators, to identify the various properties that the isolated biomolecules from the generated bacteria are going to contribute in various applications. For example, we, as Cyprus Institute of Neurology and Genetics, aim to identify the anti-cancer and antioxidant potential of the isolated compounds. Democritus University of Thrace is going to examine the anti-aging and antimicrobial capability of these targets, whereas University of Patras will characterize the isolated compounds. In addition to this, further exploitation of these compounds are going to be taken by MLK and BioFab in order to take an advantage of further utilization of such molecules. Finally, Heriot Watt is going to do a chemical characterization along with a physical identification of the properties of such compounds.
My name is Ibrahim Banat. I'm a professor of biotechnology at the University of Ulster. I think that, first of all, the best thing to say is we understand how important is the microbial cultures of microorganisms and the intimate relationship between plants and microorganisms in nature. Bacteria and fungi have an important role to play in the growth and maintenance and health of the plant population. And we aim to exploit these particular associations between these microorganisms and the plants, hopefully to allow these plants to acquire or develop new traits, particularly traits to do with resistance to the climate change that we are noticing nowadays that affects the drought conditions in many plant species, and also the change in temperature and reduction in yields, reduction in productivity. We hope to sort of ameliorate these changes that are happening because of value chain through using microorganisms. At Ulster, particularly now, we're interested in a particular bacteria called Mucilaginibacter, which our partners have discovered that it is predominant in soil samples that are quite ancient, from ancient DNA that we are able to extract. So we're looking for ancient DNA and ancient traits, ancient microbial parts of microbial cultures, to try to bring them back, to try to introduce that into existing rhizosphere microorganisms, hoping that if we add them to the soil and allow these microorganisms to form associations with these plants, we can improve their growth, improve their characteristics and ability in combating or fighting climate change. So we optimize, we isolate these cultures, these DNAs, we put them in new rhizosphere microorganisms, so we're optimizing their growth and produce biomass that we hope to introduce into the soil and into agricultural soil that is used for plant propagation, in the hope that we accelerate the evolutionary process using these old traits from old genomes that have lived through microorganisms exposed to such conditions from long time ago. So it's basically, we're trying to serve industry, not only agricultural related industry, but other pharmaceutical, other bioactive related industry in a close relationship, address these areas of issues to provide new products. Basically, in a nutshell, that's what Tolerate is hoping to achieve. And thank you very much.